Okay, so this little video, we're just going to look at the application of refraction, where we're looking at the fish underwater. So we've got air up here and our fish is in the water. Now the first thing to remember with this is that your water is going to be more optically dense than the air. Okay, so in this case the light is going to be coming from our fish from a more optically dense medium up to the surface of the water and then into the air into a less optically dense medium. So in the same way we start to construct any ray diagram, what we're going to do first of all is draw two light rays coming from a point on our fish. Okay, it doesn't matter which point we choose. So we'll just choose the front part of our fish here. So I'm going to put one ray coming up here and we'll do another one at a slightly different angle here. Okay, so those are our two rays coming from our fish. So they're going to come up towards the surface of the water. Now whenever we're doing a diagram that's involving refraction, the next thing we have to draw in are our normal lines. So remembering that our normal lines, we always draw them at 90 degrees to the surface where the ray hits the surface, and we always draw them as dotted lines. A little bit difficult with these pens. Okay, and we're going to draw another normal line where this ray hits the surface of the water here. Now when we are going from a more dense medium to a less dense medium, we have to think about which way our rays are going to move relative to the normal line. So when we're moving this way from more optically dense to less optically dense, they're going to move away from the normal line. So what we have to make sure is that when we draw the rays coming out, as they come out, our angle of incidence is here, our angle of refraction has to show that it's moving away from the normal line. So if this boundary wasn't here, our light ray would just keep moving along this line here, but because we've got a boundary going into a new less optically dense medium, we're going to move away, further away from that normal line. So that ray is going to continue in this direction, and our other ray will do exactly the same. So if we were moving without the change in substance from water to air, we would go along this line, but because we're going from more optically dense to less optically dense, again it's going to move away from the normal line, and so our ray will go in this direction. Okay, so over here is where you would be standing, so this is where your eye would be looking into the water. Now the second important thing to remember here is that our eye thinks that light travels in straight lines. So when our eye sees the light ray coming along here, it tracks back and thinks that our light ray has come along that line there. Okay, and we draw that in dotted because it is a virtual ray, and it does the same with this ray as well. So tracking back, sorry, dotted line's not working very well with this pen. We track back and we get our dotted ray here. So we can see that those rays meet at that point. Just redraw that one a little bit better. Okay. So your eye thinks that this line has come along here, and it thinks that this ray has come from this point here. So where those two rays meet would be at the front of the image of your fish. So here'd be his little eye. Now if you've drawn this diagram fairly accurately, always it should be above the object. So this is your object and here's your image. So the image in the water should be higher than the actual object, closer to the surface than the actual object. And you usually find it should be around about the same position. Don't worry if it's a little bit behind or a little bit in front. It will depend a little bit on how accurately you've drawn your diagram. So if you're asked type of question, if you know something like if there's a spear fisherman, where should he aim his spear to hit the fish? We should always say a little bit lower than where he sees it, because the image he sees will always be slightly higher than the actual fish itself. So he needs to aim a little bit lower than where he sees the fish in the water.